Thanks,
Thank you, Matt. Thank you, Robert, for this amazing opportunity. I'm Damiano, my colleague Mohammed. We did this work together in these last 3 months, improving what we had already with Walert. I don't want to be repetitive, but I would like to acknowledge country as well, and in particular introducing this artwork by Srianaham Firebrace, a Yorta Yorta artist, that is representing exactly what we are doing here today, information retrieval on country. So you can kind of guess that the Birarang River here is dividing Wurundjeri and Bunurong country. These faces here that you might recognize are the elders that are the custodians of knowledge. And then the blue island that you see on top, you can find that like you're seeing from the airplane. The blue sky, the blue islands are information access systems. One of them is Walert. I would like to recognize that what we do has an impact in Aboriginal and Torres Strait Islander people. And I would like to recognize also that we have a gap because we are non-Indigenous doing information retrieval research. So we cannot guarantee that the impact is beneficial for Aboriginal and Torres Strait Islander people. So yeah, I would like to acknowledge that. And this is a step forward, baby step towards decolonizing our research and education practices. I would like also to acknowledge the Bunurong and Woiwurrung people and their elders and ancestral and elders, past and present. We also acknowledge your elders, and I would like you to translate it in Farsi for your parents. That is a pleasure and honor to present this work that we did together to them.
گفتن که تشکر میکنم از حضورتون بابت اینجا و خیلی ممنون ازش. Thank you.
So what is Walert? Walert is a customized AI-powered chatbot that we use at OpenDay for the School of Computing Technologies because we are lazy. We don't want to answer all the questions that potential students have. So talk to Walert, but really like what it is a conversational starter because it gives us the opportunity to show the opportunities and limitations of customized AI chatbots, in particular systems like retrieval augmented generation. It shows us like to create awareness about the importance of having a robust evaluation framework and guidelines on how to test these solutions built in-house, not only for potential students, but also for industry partners that are looking at building their own ChatGPT for their own documents, that sensitive documents in-house. But also, as I said before, does anyone know what Walert is? I'll give you a hint. Anyone does recognize this animal? Walert means possum in Woiwurrung and Bunurong language. So it's an opportunity to also start a conversation about the significance of possum skin cloaks for Aboriginal and Torres Strait Islander people that are custodians of this country. The demo is available here. After we finish, we might be able to use it here in the Race Hub. So the journey so far, we started with OpenDay 2023, and from there, Walert traveled all around, including the world, because we got invited to give a demo at SIG. We had the demo paper accepted at CHEER, that is one of the main conferences in interactive information retrieval. So Sachin and Futon, that are part of the team, were lucky to go to Sheffield to show Walert to our IR community. We went to the REA group. Then we repeated OpenDay, and then we also showcases in a UBCOM conference that was here in Melbourne. So just a quick overview of what retrieval augmented generation is. Basically, is you have your documents, let's say like the documents that your research group has already, the know-how of a company. And then you break that down into passages that then you can build an index. So then typically what we would have is an information retrieval, a search engine that would look at those passages to retrieve passages that are relevant for a particular question that the user might have. The interesting aspect of the augmented part that comes with a large language model is that you can get those retrieved passages and ask a large language model to create an answer, to generate an answer built on that information. The reason why you want to have these retrieved passages that come from your knowledge base is because ChatGPT won't have the information it's particularly specific for your own organization or your company. If we ask ChatGPT straight away, what are the programs that you can get, that you can enroll in the School of Computing Technologies? Well, so the 2023 was the documents. Good luck to ChatGPT to find information from 2021, that was when the large language model was built, and in particular about RMIT. So what you want is to reduce the hallucinations by having access to retrieve passages from your own collection. Yet they think that we show with Walert that this is not solving the problem of hallucinations, it's just minimizing them. So what we did in the last 3 months is like, well, you can plug in LLM there, which one? So the first iteration that we had with Walert, we used Falcon. That was one of the main open source large language models at the time. Now we have so many, every day we have 5 new large language models. So we wanted to test, do we have any difference if we use different ones? Large language models, open source large language models, and we compare them. And in particular, we were interested in understanding what is the best options to deploy them with the infrastructure that we have at Raise. Do we want to deploy them in Amazon EC2 or also use the service for large language models already provided by Amazon Bedrock, and see what are the pros and cons of using one or another? So I'll hand over to Mohammed to talk more about this.
Thank you, Damiano. My name is Mohammed. Nice to meet you all. What we do here, as Damiano mentioned, there were 4 main open source large language models. So in the first step, we deployed open source large language models in both EC2 instances and Bedrock. And what we were looking for was to analyze their costs. In order to do so, we had the Walert benchmark, which includes 45 number of FAQs, like sample questions. So on EC2s, we could deploy all these models. But the difference, like during EIP project and the progress and improvement we made, we upgraded the previous Walert version, I would say, with use of VLLM. And the reason for that was because our EC2 instances are quite GPU-based dependent. So in order to get the maximum use of GPU resources on EC2, VLLM is a very efficient, memory-efficient library for deploying these large language models. So all these models deployed that based on this library. And for Amazon Bedrock, which is our second service, we could only use 2 models. And the reason for that is Amazon Bedrock supports limited number of models. And these 2 models were only supported with that. I will go more in detail of that in the next slide. And finally, after getting the result, we compared the 2 main things, cost of deployment of these 4 large language models and how much effective they are. So before going to process of deployment, the first question that was really important for us was, what is the minimum requirement in terms of the number of GPUs in these 4 models? So as you can see here, we found that based on the initial documentation, the first 3 models require at least 16 gigabytes of GPUs, whereas the last one required 90 gigabytes. So that helped us to select our right EC2 instance as a starting point. But interesting, what we found here, we first selected G4DN X large, which provides 16 gigabytes of GPU RAM. But when we tested these models on that, we could only generate results for the first model, and we got out of memory for the second and the third one. So we found that that documentation may not be exactly matched with what you tested. So that's why we needed a larger instance to provide more GPU resources. And that's why we selected G5X large, which has 24 number of GPUs for the second and the third model. And for Bedrock, as I mentioned earlier, these 2 models are supported in Bedrock. Obviously, it's not yet the first and the third one. They are not yet supported. This was one of the challenges, the limited supporting of models. And also another challenge was Bedrock is highly based on different regions. We have different supporting models. So, for example, in Sydney, Mixtral is only supported, but in US or Oregon State, we have Llama 3.1 and Mixtral. So these are also some challenges we had during the deployment. So for effectiveness, I'll hand it over to Damiano to give the insight about this result.
Yeah, obviously what we care about when we are building a chatbot is like when we ask a question, do we get the right answer or not? Because we want the students to come to enroll to the right program, not the one that the chatbot told them that it doesn't exist. So what we have here is a mechanism to compare the answer that is given by the chatbot and the gold answer that is, because we have the frequently asked questions database, we can compare with the true answer. And we have three types of answers. The one that you only need a passage to get the answer, the known answers. The inferred one, that is you need to combine the different passages to come up with the answer. This is the interesting, so with the known one, you could use a search engine, you find the passage and you are done. The inferred one, you need to combine multiple ones, so the answer generation is where we're really interested in. The out of knowledge is the challenging one for all AI, is understanding when to stop to give you, so when to know that the system needs to know that I don't have the answer. So, and we know that it's a challenging one, and the results show that. But when we wanted to compare how the different LLMs are behaving on these different things. So BERT score is basically semantic similarity between the correct answer and the provided answer. So what we found is that from the first LLM that we had before, so using the newer and larger models actually improves the results. And so we can see that Mixtral, for instance, which is the biggest one, is the one that gets the highest results for known and inferred. Out of knowledge is still a challenge, which means that it's actually showing us that retrieval augmented generation only doesn't solve the problem of hallucinations fully. And then the other thing that so the question complexity, there's an inverse correlation between complexity and effectiveness.
So what are the takeaways? And if you want to highlight here, so we discussed and we introduced the Walert, retrieval augmented generation for FAQs. We did cost performance analysis, and what is important, which also like for deployment of LLMs, which one, EC2 or Bedrock, and what factors are important. And what we found, in addition to cost, flexibility, expertise, and the scale of the project are some other key factors for selecting the right service. We make an estimation based on the Walert benchmark to help practitioners to make an informed decision based on their number of tokens. How much does that cost on both EC2 and Bedrock? And also we found that the official documentation of LLM does not give you the full picture as we tested, because like what we mentioned about the minimum GPU requirement, you may get different result or out of memory result with your testing, but with following the documentation. But most importantly, and the key message we want to say is, this work, we believe that is a step forward towards cost-effective use of open source LLMs in research. So thank you so much. We would like to thank you, Pat, from our race team, and Sachin from Walert team. And yeah, please ask your question if you so. Thank you.